Okay, so we have Thomas who does chores for his aunt, and she uses this spinner to decide which one he's going to do. So what we know is that raking leaves and doing the laundry are the same probability on this spinner. Clean the bathroom and vacuum are the same on this spinner, and we're trying to figure out what is the probability of doing the laundry. So in our notes, let's go ahead and figure these out. So first we're going to figure out doing the laundry. So we know that vacuum and bathroom are the same, so that means that bathroom must also be 1/4. And then since clean the bathroom is 1/3, we have just this part missing. So how can we figure out what part is missing? Okay, so this is problem 119. We're trying to figure out for part A, what is the probability of landing on laundry? All right, so we're figuring if this part of the spinner is missing, this part is not missing, we can figure out what all of this is and just kind of subtract it from everything else that is missing. Subtract it from the whole entire to find out what is missing. So in order to do that, we have to change these to a common denominator. So this would be 3/12 probability to clean the bathroom, 3/12 probability to vacuum, and 4/12 probability to clean the bedroom. Okay, so once we find that out, we now have numbers that we can add. So we have 3/12 plus 3/12 plus 4/12, and that will give us 10/12. Okay, but we have to remember that 10/12 is what is not missing. So we have to figure out what is missing, and the way we do that is we just take it away from the whole. So if we take all of this away from the entire one, which would be 12/12, then we can figure out what those two pieces are, and since they're the same, we would divide by 2. So here's the work. We have 12/12 minus 10/12, which is 2/12. So that means that these two together make 2/12, and since they're both the same, that means that the probability of laundry is 1/12. Right? So we would just divide this by 2. So our next question is, he doesn't like to clean the bathroom, so he wants to figure out what is his probability of not cleaning the bathroom. And this is question B. What is the probability of not cleaning the bathroom? Okay, and again, we're going to find out what is all of this. All of this. Take away from the whole, because cleaning the bathroom, that probability is 1/4. So that must mean the probability of everything else must be that 1/4 taken away from the entire 4/4, which will give you 3/4 probability, right? So we just take this part away from the whole entire spinner, and that'll give us 3/4 right here. So 3/4 probability of not getting clean the bathroom. So what this number is called is a complement. The complement is the probability of not getting something where we just take it away from the whole. Okay, so 3/4 is called the complement because it completes the whole from the probability of cleaning the bathroom. All right. So our next question. What is the probability of cleaning the bedroom, and what is the probability of raking the leaves? Well, we know that the bedroom is 1/3. We know raking the leaves is 1/12, and either chore would make his aunt happy. So what is the probability that what is the probability of getting either cleaning the bathroom or raking the leaves? Okay, so this is probability, this is problem number 120. question A, we know the probability of the bedroom, we'll just put bed, is 4/12, because we know that we're going to be dealing with sums and differences here. So the bedroom is 4/12, and we know that raking the leaves is 1/12. Now keep in mind that both of these would make Aunt happy. So if we landed here, Aunt's happy. Here, Aunt's happy. Here, Aunt's happy. Anywhere of these areas, Aunt's happy. So this whole area, Aunt is happy. So we're trying to figure out what is the probability of getting the bedroom or raking the leaves. In other words, where the Aunt will be happy with either one. So this whole area. And in order to do that, all we need to do is find the sum. Okay, we need to find the sum of the bedroom and the leaves. So that's 4/12 plus 1/12, because remember, both of these would make Aunt happy. Not happy, not happy, not happy. We take those away. So that would give us a 5/12 probability. Okay, so what we just did is a very important concept, and that is whenever we have the probability of something or something happening, we're basically looking for the sum of those two probabilities, because both would qualify for making Aunt happy. All right, and next question, Ms. Nguyen lets students borrow pens, and there's wooden pencils, mechanical pencils, and blue pens. 1 out of every 3 students gets a wooden pencil when they reach in. 2 out of every 5 gets a mechanical pencil, and the rest are blue pens. Is he more likely to get a wooden pencil or a mechanical pencil? So let's work that out. So we have number 121. We have the probability of a wooden pencil, which is 1 out of every 3 students will get a wooden pencil, and 2 out of every student is going to get a mechanical pencil. So that's a probability of 2/5. Now, which one is more likely? Keep in mind, there's also a blue pen, which is the rest of the entire whole. Okay, so the probability of getting either pencil, well, first of all, which one's bigger, 1/3 or 1/5? And we can change these to decimals is one way. That's 0.3 repeating, and that's 0.4. So it's more likely to get a mechanical pencil. What is the probability that that pencil is going to be wooden or mechanical? And again, we're going to add those probabilities in order to find out the probability of wooden or mechanical. So this is the same thing as probability of a wooden pencil plus the probability of a mechanical pencil. Right? And that would give us a probability of, see, 1/3 plus 2/5. We would just change those to having a common denominator. That would give us 5/15 plus 6/15, which is 11/15. Okay, so this is the probability of getting a pencil. This is the probability of any pencil. Is 11/15. And then the probability of getting a pen, so let's figure that out. What is the probability of getting a pen, which is the complement of getting a pencil? If you're getting a pen, you are not getting a pencil. And so 11/15 is the probability of getting a pencil, and the complement of that would be the whole bag of writing utensils minus the probability of getting pencils. And there is the probability of getting a pen. All right, and there's that concept again where we have the probability of wooden or mechanical pencil, and we're adding them. Same thing as the probability of any pencil. Alright, so let's get to the next concepts. This is showing adding those numbers, how to do it wrong. Okay, so Lindsay has a full bag of Tutti Frutti Chews in different flavors. If you reach into the bag, you have 1/3 chance of pulling out a killer kiwi. There's 3/5 chance that you'll get crazy coconut. What is the probability of coconut or kiwi? Alright, so let's set that up. This is number 131 in the book. So you have the probability of kiwi is 1/3, and the probability of coconut is 3/5. What is the probability of getting kiwi or coconut? That means, again, or means that we are going to add those probabilities. So we are going to get the sum, which is 1/3 plus 3/5. And since we need a common denominator, we're going to change that to 15ths. 5/15 plus 9/15, and we get 14/15 probability of getting kiwi or coconut. Okay, and what this means, well, again, let's highlight this important point again. I can't say it enough. Or means that we're taking the sum of it. Okay, so 14/15 probability of getting a kiwi or coconut, and the next question is asking, does there have to be another flavor? And the answer is yes, there is another flavor, and the probability of the other flavor is the complement of it not being kiwi or coconut, or the complement of kiwi or coconut. All right, and the probability of the other is 1/15. Okay, so probability of another flavor. Now, the question that follows is there only one more candy flavor? So, how many more flavors are there? Or can there be? Can there be only one more flavor? And the answer is yes, there can be one more flavor if there's a bag of 15 candies. But the next question is, how many candies can be in the bag? Can there be more than 15 candies in the bag? And the answer is yes, there can be 30 candies in the bag. If there's 30 candies in the bag, then how many are not kiwi or coconut? And the answer is 2 of them. So do they have to be one flavor, or can they be different flavors? Okay, so this is still a probability of another flavor. That's still 1/15. But this is saying there could be 30 in the bag. And if there's 30 in the bag, 2 of them are not kiwi and coconut. There can also be 90 in the bag. And if there's 90 in the bag, then that means that how many of them are not kiwi and coconut? 6 of them. So there could possibly be 6 different flavors. There can be 900. That means there's 60 different flavors, and so on and so on. You can keep going on this one. So how many more can there be? There can be many more. And let's go to the next problem, number 132. Okay, so this problem says, Lyle asked for a challenge problem, and his teacher gave him this one. There's 2/7 chance of drawing a red marble out of the bag, and the probability of drawing a red or a blue one is 2/3. What's the probability of getting a blue marble? All right, so let's work this one out. Probability of getting a red is 2/7, and the probability of red or blue is 2/3 probability. What is the probability of getting a blue? All right, and let's work this one out.